Everyone, welcome back. In this video, we are going to review parent functions, and in the next video, we are going to talk about function transformations. These are very related topics. So first of all, again, as always, what is a parent function? So you can see I've listed out quite a few functions there on the left-hand side of the screen. This is just using Desmos Graphing Calculator online. So you can see there are multiple parent functions. You're going to focus some on more than others. It really just depends on your teacher as to like which specific ones you're going to have to know. But this is a pretty good general list. You can also always just go to Google Images and type in parent functions, and you're going to find various worksheets that list all of them. But these ones are definitely the most common ones that you're going to see and have to know. So first one there at the top is y equals x. This is just called the linear parent function. So if you think of the word linear, what does it mean? Well, it means it's a straight line, right? So you can see it there. It's graphed in red, literally just a straight line going through the origin, which is the point 0, 0. Second one that is important to know is this absolute value function. So you can actually notice, this is kind of cool, if I plot these together, we probably know at this point that the absolute value just takes the values inside and makes them positive, which is really what you see here on the graph, right? If you took this red part of this graph over here, and you flipped it up, right, or made those value positive, you would get this absolute value function. So anyways, this just has a V shape. It has a slope of 1 over here on the right. It has a slope of 1 over here on the left. And again, just two straight lines that make the shape of a V. Okay, moving on. This is the quadratic parent function, which makes this parabolic shape or parabola shape. And you can see here it kind of looks like a U. Again, this is a very common function in Algebra 2. It is used to model like projectile motion, right? So if you're like throwing a ball, launching a cannon, anything that's going to kind of go up and come down due to gravity, this is a very common parent function to model that situation. All right, moving on. This is the cubic function. You can see here the right side goes up, the left side goes down. Again, it passes through the origin here at 0, 0. And yeah, that's about it. All right, moving on. This is the square root function. Basically starts at the origin, goes up this way on forever to infinity. This parent function is the first one we've seen so far that has a restricted domain. So domain is all possible input values, right? This graph doesn't exist over here for these negative values at all. Why? Because you can't take the square root of a negative number without going into imaginary numbers, which is a topic for another day. But not using the real number system, you can't take the square root of a negative number. So this has a restricted domain of 0 to positive infinity. All right, moving on. Here we have the cube root function. You can see it looks pretty similar on the right side to the square root function. Not exact, but pretty similar. However, this does not have a restricted domain, right? This goes on forever in both directions. All right, moving on. This is usually called the reciprocal function because it's 1 over x, right? It's the reciprocal of x. And you can see here, this graph is rational and it has two asymptotes. It has a vertical asymptote at x equals 0, which is kind of here. I like to think of asymptotes as kind of like fences for the function. And then it also has a horizontal asymptote here at y equals 0. All right, moving on. Let's take a look at a log function. So you can see here, this log function, again, the domain is really important here. You can see it doesn't exist at all over here on the left side, right? It only exists over here. So the domain of this would be x is greater than 0. It has an asymptote here at x equals 0. So note that I was careful not to include 0 in the domain. This is actually x is greater than 0. Whereas this one, it could actually equal 0. So this would be x is greater than or equal to 0. This is just greater than. Okay, good. And then let's take a look at an example of e to the x. This is an exponential function. I chose to use e, but really I was just kind of generalizing for any exponential function like that. It could be y equals 2 to the power of x, y equals 5 to the power of x, anything is going to have kind of roughly the same shape. And don't worry, I'll kind of show you that in a second. Anyways, key things to note here, the domain is all real numbers, right? Going left and right, it exists for all values. However, this has a limited range. So range is going up and down. And notice this graph doesn't exist down here at all. So the range of this function is y is greater than 0. Again, it has a horizontal asymptote here at y equals 0. All right, so let's actually call it there for now. Maybe back in the next video, because we're going to start to talk about these functions more in depth, and also I'm going to show you how to transform these functions. All right, thanks so much for watching. See you in the next one.